Let's dive deeper into conversational AI, breaking it down into its key components, how it functions, its applications, strengths, limitations, and where it's headed. I'll aim to explain this from the ground up, keeping it clear and thorough. What is conversational AI? Conversational AI is a subset of artificial intelligence designed to enable machines to understand, process, and respond to human language in a way that feels natural. Think of it as a bridge between human communication and computational power. It's not just about parroting pre-programmed responses. It's about interpreting intent, maintaining context, and generating replies that align with the user's expectations. Systems like Grok, built by xAI, are examples of this technology in action, aiming to provide helpful and truthful answers. Key components. Conversational AI relies on several interlocking technologies. Natural language processing, NLP. This is the heart of the system. NLP allows the AI to break down and interpret human language. It involves tokenization, splitting sentences into words or phrases. Syntax analysis, understanding grammatical structure. Semantic analysis, grasping meaning and intent, e.g., distinguishing "I'm cold" as a statement vs. a request for a blanket. Context tracking, remembering earlier parts of a conversation to stay coherent. Like how I know you're asking for more detail now because of your first question. NLP uses statistical models and neural networks trained on vast text corpora to predict what words or phrases mean in context. Machine learning, Milliliter. Milliliter powers the AI's ability to learn and improve. Deep learning models, like transformers, the architecture behind many modern IS, analyze patterns in data to generate responses. For instance, I'm trained on diverse texts to understand how humans explain things, argue, or ask questions. Reinforcement learning can also fine-tune responses based on feedback, though that's more common in systems designed to optimize specific goals, e.g., customer satisfaction. Natural language generation, NLG. This is the flip side of NLP, turning the AI's internal understanding into human-readable or speakable output. NLG decides how to phrase things, balancing clarity, tone, and relevance. For example, I could say, conversational AI is cool, or give you this detailed breakdown. NLG helps me pick the right level. Speech recognition, optional, for voice-based systems, e.g., Alexa. This converts spoken words into text. It's not my domain since I'm text only, but it's crucial for many conversational AI applications, knowledge base or external tools. Some systems, including me, can tap into external data, like web searches or specific datasets, to supplement their training. This keeps answers fresh and grounded in real-world info when needed. How it works, step by step. Imagine you ask me, how does conversational AI work? Here's what happens behind the scenes. Input processing. Your text gets fed into my system. NLP dissects it, recognizing how as a query, does as an action indicator, and conversational AI as the subject. Intent recognition. I figure out you want an explanation, not a history lesson or a yes/no answer. Context check. I note your earlier question about conversational AI, so I'll build on that rather than starting from scratch. Response generation. My ML models draw on training data to craft an answer, aiming for clarity and depth since you asked for detail. Output. I deliver this explanation, tweaking the language to sound natural and engaging. Applications. Conversational AI is everywhere, adapting to different needs. Customer service. Chatbots handle fax, bookings, or complaints, e.g., "Where's my package?" Quote. Personal assistants. Siri, Google Assistant, or Alexa manage tasks like setting alarms or playing music. Healthcare. AI triages symptoms or schedules appointments. Education. Tools explain concepts or tutor students. Research and exploration. Systems like me answer complex questions, often with a focus on truth and first principles, as XAI intends. Entertainment. AI companions in games or apps keep users engaged. Strengths. Speed and scale. It can handle thousands of conversations instantly, far beyond human capacity. Consistency. No mood swings. Responses stay uniform, unless programmed otherwise. Accessibility. Available 24/7, in multiple languages, for anyone with a device. Adaptability. With training, it tackles diverse topics, from tech to philosophy. Limitations. Ambiguity. It can misinterpret vague or sarcastic inputs, e.g., "nice job," "genius," might confuse a less advanced system. Emotional depth. It mimics empathy but doesn't feel it. Great for facts, less so for heartfelt talks. Bias. Training data can embed human biases, leading to skewed outputs if not carefully managed. Specialization gaps. Highly niche or cutting-edge topics might stump it without real-time data access. Context limits. Long conversations can strain memory, causing drift from earlier points. The future. Conversational AI is racing forward. Companies like XAI are pushing for systems that don't just chat but reason. Think AI that can debate, hypothesize, or solve novel problems alongside humans. Advances in multimodal AI, handling text, images, etc., and real-time learning will make it more dynamic. Imagine an AI that not only explains conversational AI but sketches a diagram on the fly or learns from your feedback mid-chat. Ethical questions, like ensuring transparency and avoiding over-reliance, will also shape its path.